we looking for? Is we're looking for any place we have a variable that could be pointing to an object, and then I change the value of that pointer, either by setting it to null or some other value. Do I do that anywhere in this code? Actually, I had, yes. Pending job equals null, exactly. So right here, I need to do free rep. Right, because at this point, what's the reference count? For that, the object that pending job pointed to, what's its reference count? 0. So this was a previous call, save the J in there. It eventually will have a reference count of 1. We'll have to figure out how that happens. Because pending job will be the only pointer to it. And so now when I say free ref, the object gets free. Any other place where I need to do a free ref?
Pending job is J.
What do you think? It's a good thought. You have to read the code carefully, though, to see whether that makes sense. What's the value of pending job at that line of code? No. Yeah. So, of course, you could do this. Which is the same thing as if pending job does not equal null. In C, as in some other languages, integers have Boolean values. So any integer, any number, including pointers, that is 0 is considered to be false, and any other value is considered true. So that line is the same as saying does not equal null. But I know it'll always be null, because I set it to null here. If it's not, that's what this line is doing. If it's not null, I do this and set it to null. I don't know what the else was for. Maybe there's something I'm supposed to do there. Okay. So any place else? Okay, now what about J? So J, this is a bit tricky here. J is a variable and it's going away. So should I do this? No, why not? So you're shaking your head, why not? Yeah, so J would go to 0 at this point. And so what actually happened is that I could do this. I could say, well, look, I've got a new reference here. This is correct. That's perfectly fine. Because, look, start job was called by organized job. And that J is still there, right? It's 1 now. So I could say, well, you know, now I kind of have 2. But anytime you have this, keep ref, free ref, that's pointless. And the thing with manual reference counting is you want to keep the code as simple as possible. So there's no benefit to doing that. You could do it, it's correct. But it's just extra stuff to do. So in this case, I'm just going to treat the J in both cases, as just focusing on the one that's in scope. So it's already 1, it's 1 for me, it's 1 for the other thing, but neither one of those J's can be used at the same time, so it's okay. But if you're more comfortable, it's perfectly fine to say keep ref at the beginning and free ref at the end.
So is C pass that pointer by value, so it creates
Yeah, it's passed by value, so there actually literally are 2 J's. And we'll talk about how this works after the break, when we talk about the stack. Is that, everybody comfortable with that? So part of what happens when you're using reference counting is you're engineering this. This is you're thinking about where should you put the keep ref and free ref. And you want to do it in a way that's simplest, easiest to understand, easiest to read, and also correct. And that's what I'm doing here. So now, so that's fine here. Every place that a reference can possibly go away, in start job, I put a free ref. The last one is right here. Anything I need to do there. Discuss this. Anything I need to do there. So do I need to call free ref an organized job? Raise your hand if you think so, yes. No. Ooh, not sure. Interesting. Well, at the beginning of organized job, I have a pointer J. And the ref count is what? 1. And J is pointing to it. At the end, like after this returns, do I still have that variable J? No. Are there any variables that are pointing to this object? No, because the caller of organized job doesn't have a pointer to J. Right? There's still a pointer to that object there, but I haven't decremented the reference count. And so that's a memory leak. So I do have to free it. Does that make sense? J is going away. It's the last, it has a reference. That call to create job passed it a reference. At that point, the only reference in the program to this object is J. It has a reference count of 1. And so if J goes away and I just passed it somewhere else, then I need to decrement. Does this make sense?
Yeah.
So, where do I do that? What about here?
No.
I heard a very emphatic no. Why?
You need to save the data in the variable first, because if you do free, and then because you need to be able to return the data. If you free,
So, right, so free ref, when the reference count is 1, free ref will free the object. So, because in this case reference count is 1 before the call to free ref, after the call to free ref, J is a dangling point. So you have to be aware of this, is any time you call free ref, maybe the object is gone. It depends on what the current reference count is. And this particular module doesn't know, it doesn't care. It's just managing its own reference.
Since free ref doesn't actually change anything in memory, then wouldn't that still?
It actually still would work in this case, but it's still bad. Still a dangling pointer, still bad. So, so that is not good. What about that?
wrong.
Okay, I love this because perhaps this will never happen, but on exams, we'll have a question like this on both the provisional and the final. People do that. So nothing executes after return, right? Return is the management, the control flow of that procedure. Now, I get it. What you want to say is, I want it to be free, like after I get the data, but before it actually returns. Right? And there's actually no way to do that other than what you suggested, which is what? So I look up here and say, what's the type of data? Data is an int. So I'm going to say, have a temporary variable to store the data. And then I can call our cpref. And then return t. Okay. Make sense? Okay. Those are basically all the tricks. There's one more thing here is that if you look at this code here, this line is kind of unnecessary. I already sort of did this, but let's just do that. What if I comment out that line? What has to change? Discuss this with each other. What if- Actually, if I meant to do this too. Come out both of you. Sorry. If I didn't set it to null, I shouldn't be calling free round. There's no point. So this is, what has to change is I have to free the rep right here. Right before I change pending job. So I say if pending job or some free rep or you don't need it. The equal no part, obviously, you're about to change it. So either of those is perfectly fine. I think this will work now. So skip 1, started 2, completed 2, started 3, completed 3, skip 4, completed 3. What? That's because I did this. I think. Started 3, completed 3, skipped 4, started 5, completed 5, total 30. So that's correct. But I don't know for sure unless I run val grind on it, because I could still have a memory leak. So I'm going to copy this over to the other machine and get it run on Linux. And here I am. I have to delete the executables and remake them for Linux. Again, seems to work. And this is what you're looking for in Linux possible in that particular execution. Okay? Questions about this? Okay, so to summarize, what we do with dynamic allocation in C not quite sure where to. There's another example, by the way, we'll post that you can use to get some more practice if you want it. Start there. So to summarize, what we do with dynamic allocation in C is if the allocation is just local to a module, I allocate something free, and I don't use reference counts. But what I do is I co-locate the alloc and the free in the same module if possible in the same procedure. So that's what we looked at in the beginning. Then in cases where the multiple modules have to share an object, I use reference counting instead of calling malloc and free, so that each module just keeps track of its own references, and they don't have to know what the other modules are doing. They tell the object if they have a reference, they tell the object when they don't have a reference. And when the references go to 0, the object is free. So in some ways, this is like garbage collection. So garbage collection, as we've talked about, is a technique that is used in Java and in Python and JavaScript, where occasionally in the background a process will run and it will follow all the pointers in your program to find every object that you can possibly reach in your program. And it marks all those as reachable, and then everything else, because it knows where all the objects are, is garbage and it sweeps them away. It's called mark and sweep. Garbage collection. Okay. So there are some advantages to garbage collection. One is that you can't possibly have dangling pointers. There's another one here which I'll just refer to briefly in a second, having to do with cycles. This is a problem with, potential problem with reference counting. But you can't have memory leaks in Java. So how does a memory leak occur in Java? Remember, a memory leak is when you don't call free, what you call free. How many people have written a Java program? How many people have written a Java program with a memory leak? Just keep your hands up. How does it happen? No, so that's one answer. So one thing about garbage collection is that garbage piles up for a while before it's swept away. But that is not a memory leak, because what we're really worried about is eventually does it go away. So that does create some issues. You don't have that problem with reference counting or with explicit delete. That's a good point. But no, it's something else.
Isn't when you create an object in the vector?
No, so if I say new, let's say x equals new, and x is a local variable, and that procedure returns, the x goes away, there's no pointers to it, the object will be freed, it becomes garbage. But if I happen to save a pointer to it somewhere, it'll never be freed. So an example of this is a hash map. So who's used a hash map? What are the methods of a hash map? The public interface is
You have like
put and get. So how many people have used put? How many people use get? Of course. Are you aware that there's another method? Delete. How many people have used delete? Nobody. Oh, okay. Some people. Nobody deletes things from hash maps. Well, as soon as you put something in a hash map, that will never, ever be collected. Because the hash map's holding on to it. And this is very common. So like if you had a web server or something like this, every time a web request would come in, maybe you put something in the hash map and process that request. But when the request is done, you need to get rid of that stuff. It's garbage now. It's stuff from the previous request. You put an hash map, it'll stay forever. So there's a technique for dealing with this called weak pointers that you might want to look at if you're writing Java program out in co-op Java. But we're not going to talk about it. So let's recap here by comparing explicit delete and garbage collection. So here's 4 questions. What are the advantages of explicit delete? What are the advantages of reference counting? What are the advantages of garbage collection? And then this final one, which I kind of just answered, is it okay to ignore the allocation of Java programs? So discuss those with each other. not, there is an advantage to explicit delete. So what is the advantage of explicit delete over garbage collection?
You're not, oh,
Or, well, whatever you're gonna answer.
I would say over reference counting, you don't have the extra 8 bytes you're allocating every time you go.
So compared to reference counting, let's just say it's simpler, right? Just malloc free. So you should use that instead of reference counting if you can. Absolutely. But compared to garbage collection.
It's probably easier on the system, uses less resources,
Uses less memory. Why is that?
because it's only gonna happen when you explicitly ask it to, as opposed to Java's
Right. So
constantly.
exactly. Sorry, you had the perfect answer. So it's with explicit delete, as soon as you know that something is garbage, you delete it and it goes away, and that memory can be reused immediately. Whereas in a garbage collected language, you don't say that, so the system has to periodically run the collector to figure that out. And so if you look at sort of the amount of garbage, this is what we were talking about earlier, garbage in a program, a well-written C program never has any garbage, but a well-written Java program will build up garbage, and then the collector comes and then build up garbage. So that garbage that builds up is a waste of memory. Now, when the collector runs, it needs to consume CPU resources, and mostly it will run in parallel with your program, but it actually does have to stop your program briefly to finish collection. And that, when it stops your program, so first of all, there's the CPU resources, so that's not needed in a reference counting or explicit delete language. But the second thing is that this periodically stopping program is not appropriate in some settings. So imagine that we implemented the flight control system for commercial airlines. Right, so this is, so pilots fly planes with a trackpad, and joystick, and it's just a computer. There's no connection, physical connection between the cockpit and the rest of the plane. It's all done by computers. And you wrote it in Java, and the pilot's about to land the plane, and at a particular second of landing, the pilot wants to abort the landing, and so she pulls up on the little landing stick, whatever it is, and right at that moment, the garbage collector is running. Okay, so it's not good. So real-time systems would never be written in garbage collected language. In fact, it's prohibited by people who, in fact, most dynamic allocation factors are prohibited. Okay, so what's the advantage of reference counting? You do it right, you get no dangling pointers, and no semantic coupling. So we're using this just in cases where we've got multiple modules sharing things. What's the advantage of garbage collection? You mostly can ignore the allocation. Mostly, you can't possibly create a dangling pointer. It is impossible. It's still possible with reference counting, since it's manual, you might make a mistake. It's called pre-ref when you should. But that sort of, the fact that it's so easy in Java leads to this problem we have with Java, with people leaving garbage around. And so most Java programs tend to have memory that's more than the C and C++ programs. The final thing, which I mentioned previously, is you can do reference counting automatically. So Swift and Objective-C on Apple's platforms, iOS and macOS, that's the way they do it. So it's automatic. The keep ref and the free ref are added by the compiler. But this creates a problem, which I'll just briefly show. So what if I have two objects that are pointing to each other, and nothing points to them? What's the reference count of those objects? 1. In a manual reference counting system, I could not count those. I can decide where to put the key ref. But when I'm doing it automatically, it's going to be 1 and 1. But that's garbage because there's nothing pointing to it. So it's the same technique is needed. They're called weak pointers. And again, I'm not going to talk about it, but you need weak pointers in both garbage collected and also in automatic reference counting languages, so that you avoid creating connections that hold on to objects. Like, I don't want this to hold on to them. I want this. If I have a pointer to that, that I can get to it, that's a strong reference piece of weak reference. So There's more to this picture, and for garbage collection in Java, weak reference in Java is in the slide, but you can safely ignore it. Okay, see you Wednesday.